link in the description. You can follow that to understand what permutations are. So assuming that you already know the permutations, symmetric groups are actually nothing but what? They are the collection of all permutations on n symbols. And the collection of all permutations on n symbols is actually denoted by Sm, and the order of Sm in general is n factorial. And right here, order of Sm is actually n factorial. So this is an example of a finite group. So I'm not going to go in details of showing Sn is a group. The operation on Sn will be composition of permutations, similar as we saw in case of dihedral group D4. So there as well the binary operation was composition of functions actually. In this case we are having composition of permutations. And permutations are nothing but bijective functions. So today I will directly write down the number of elements in S1, S2, S3 and S4. Writing the elements of S1 and S2 is simple, there is no issue. So the main important thing is to understand how to write the elements of S3 and S4. So here I am going to use cyclic notation for permutations. So on n symbols, on n is equal to 1 symbols, it is actually just a cycle of length 1. So it is actually collection of this permutation, that is 1 maps to 1. Next, talking about permutations on 2 symbols, that is S2, it is 1 maps to 1, 2 maps to 2. This is the identity permutation, or you can say identity element of our group. Then we have 1. So if I want to elaborate it, the first one is actually the identity 1, somewhat like this. 1 maps to 1, 2 maps to 2, and the second one is somewhat like this. One maps to 2, 2 maps to 1. Next, writing the elements of S3. So this is on 3 symbols. So for identity element, I am going to use the notation E now. It means that 1 maps to 1, 2 maps to 2, and 3 maps to 3. Now, since n is equal to 3, so this is going on 3 symbols, namely 1, 2, and 3. So first of all, what I will do is, I will write down cycles of length 2, and later on I will write down cycles of length 3. So first of all, I will take 1 and 2 together. So cycle of length 2, that is 1, 2. Then I will have this 1, 3. So it will be cycle of length 2 once again, that is nothing but a transposition. And finally I will take this 2, 3. So this covers all the cycles of length 2. Now I will move towards cycle of length 3, and that is nothing but 1, 2, 3. Now I will write the inverse of this one, and inverse of this one is nothing but the same cycle in reverse order. So this is actually nothing but 3, 2 and 1. So this is how we will write elements of S3. Now similarly, we have to write the elements of S4 as well. Now there is a trick in order to write the elements of S4. Now this is going on 4 symbols, 1, 2, 3 and 4. So first of all, naturally I will write down identity element. Now I will take cycles of length 2. I will write down all the cycles of length 2 in fact. So first of all, naturally I have 1, 2, then 1, 3, then 1, 4, right? 1, 2, then 1, 3, then 1, 4. Now we'll go for 2, 3, 2, 4. finally I will go for so this covers all the cycles of length 2. Now what I will do is I am going to use one trick here. I will just combine this one and this one together, take the product of these two permutations. So I will get 1, 2, 3, 4. Next, take product of these two permutations now. Firstly, I have taken product of these two. Now we have to take product of these two. So that will be 1, 3, 2, 4. And finally product of this two. That is 1, 4, 2. Remember the number of elements in S4 are 4 factorial. So 24, right? So we have to write all the 24 elements here. Next, the trick is now just combine this together into one cycle having length 4. So this will be 1, 2, 3, 4. Then 1. What I will do is I will simply swipe these two positions. Again, I am going to write down cycles of length 4. All the cycles of length 4 are not covered yet. So what we have to do is just interchange these last two elements. So it will be 1, 2, 4, 3, 1, 3, 4, 2, and 1, 4, 3, 2. That completes all the cycles of length 4. Now I will move towards cycles of length 3. The logic remains same as done previously. So we have to pick 3 elements from this 4 symbols. So first of all I go for 1, 2, 3. So 1, 2, 3. Then I go for 1, 2, 4. Then I go for 1, 3, 4. And then I go for 2, 3, 4. So what I did? 1, 2, 3. Then 1, 2, 4. And then 1, 3, 4. Now we are taking 2, 3, 4 together. Now we have to write down the inverses of these 3 cycles. So again, the same cycles in the reverse order. So what I will get here? 3, 2, 1, 4, 2, 1, 4, 3, 1, and 4, 3. And this covers entire 24 elements of the symmetric group. Yes.